one more presenter, Joseph Osborne. Joseph is majoring in geography. He focuses on climatology. He's mentored by Dr. Robert Hellstrom in the Department of Geography. Joe's presentation is titled Bear Sense, Bridgewater State University's Economical Approach to Real-Time Sensing.
How's it going? Thank you for being here. So what is Bear Sense? Bear Sense was designed to be a framework that could be easily deployable, easily replicated, and easily modified to any kind of environmental sensing that you would want to do. The main objectives for the project, they need to be cost effective. This project I focused on building a weather station. That was the proof of concept. And need to be competitive with commercially available systems. The parts need to be internationally available as well. It need to be able to be built and modified by someone with limited electronics or programming experience. And we need to have the data be available online from anywhere. And it goes without saying we need to be reliable. So how did I get there? The first step, I needed to figure out hardware selection. Two paths I was looking at. One was with a microcontroller. One was a single board computer. For those who don't know, the difference is a single board computer is essentially a computer. It's the same thing that's in this, in this pedestal. Has an operating system. You can use it to, it just doesn't have the horsepower. A microcontroller is, you load the code on it, it does one thing and does it well. Ultimately, I selected a single board computer. It gave me a lot more flexibility, a lot more horsepower to play with, and just a lot more ability to modify and extend it in the future. I then needed to select the programming language I wanted to use, and that was a pretty simple, easy selection for me. I wanted to, one of the personal goals for me for this project was I wanted to learn Python. I also felt Python was kind of like a low-hanging fruit for programming languages. It's a little bit more intuitive. It's being taught in K through 12. It's being taught as an intro college courses. So the type of people that would be able to go into it easily would be broad. So the initial prototype, I built ultimately two of these weather stations. The first I built at my house. It was really designed to be a test bed, testing code. I learned a lot of bugs in the physical design, modified it. And then that brings me to the field deployment. We partnered with the Soul Homestead in Middleborough, Massachusetts. They are an education center, nonprofit, but they also have an active working farm. And the benefit of being there, we also had an on-set weather station as well. So that allows us to compare data between the two. So some of the results from that, the data is really comparable. My weather station had 0 downtime, and the cost was 20%, under 20% of the commercial available system. So the graphs here, a little bit hard to see probably, but the solid blue line is my data. The dotted red line is the onset. The top one, ambient temperature, within roughly ½ degree Celsius. The Bear Sense, the wind speed is the second graph. The Bear Sense weather station is actually more sensitive, especially at lower wind speeds. I was able to measure 0.08 miles per hour, where you had dead zones. The last graph, this was basically, I wanted to present this because this was something I learned from. the sensor that I used, the sensor on the probe was in a different location than I thought it was. What that translated into is that my sensor is actually not as deep into the ground as the onset. So you have the sharper spikes compared to the onset's sensor. So one thing I wanted to give back to the Soul Homestead was the community engagement piece. I built this display box. You have these buttons here. You walk up to it, press a button, it gives you the live data. It also has a sensor in the barn, so this whole homestead can go in and monitor the barn temperature when they have animals. But primarily it was, because they're an education center, it was designed to really be a communication start. You know, getting these students that they do a lot of K-12, just starting that dialogue for weather and you know, just how weather relates to how your fruit grows. So what's next? From this project, I actually have a handful of different things already started. The first is I'm working with a fellow BSU student to develop a class. We're looking at working with a makerspace in Middleborough and teaching how to build these. Barrisons in Ohio. We're partnering with Ohio State University, and one of these weather stations is going to be deployed at a farm in Columbus, Ohio. And then sensor expansion. So I'm actually working on getting the soil moisture sensors into a microcontroller configuration so I can expand them across the field for cheaper. And then fish sense. We have aquariums at home, so one of the things that I'm hoping to do over the Christmas break is to kind of figure out how I can transform this into like an automation. Yeah. I want to thank Dr. Robert Hellstrom as my mentor, Meg Riley, who is the executive director of the Soul Homestead, and obviously ATP. Thank you.
Questions? Thank you.
So if you were to switch, you said you wanted to switch to a microcontroller to build more of them.
Yep.
Would it be difficult to, would you have to get new like sensing equipment or write new programs, or is it, do you think what you have now is compatible with?
That it's a little bit of both. So I'm using Python, and I'm using CircuitPython and MicroPython on the microcontrollers. So a lot of that code translates right over.
Cool.
So I actually have a sample of one of the boards if you want to see it closer.
Yeah, that'd be awesome.
Yes?
What would fish sense do?
Basically historic logging of parameters like temperature and stuff at first. We have a saltwater tank, so that might also include, you know, automatic dosing at some point. So again, I'm just trying to map that out. So.
Anyone else? One more.
Yep.
Just a plug for the issue currently called Shark Tank, but it's going to be called something coming in the spring because we can't keep plagiarizing Shark Tank. But consider applying for that because that could also help you launch if you want to take this into some kind of commercial enterprise.
Okay, awesome. Thank you.
That just makes it better.
Very good.